Hello viewers, in today's class we are going to solve one important definite integral involving greatest integer function, right? So here we have the integral from 0 to pi by 2 and greatest integer cos 2x, right? So let us start. So let us call this integral as I, right? So let us put t is equal to cos 2x, right? So here we are making the substitution for cos 2x is equal to t. So now dt over dx is equal to minus 2 sine 2x. The derivative of cos 2x is minus 2 sine 2x, right? Now sine 2x can be written as square root of 1 minus cos square 2x, right? So this is the identity, and we can write sine 2x as square root of 1 minus cos square 2x. Now this can be written as minus 2 square root of 1 minus for cos 2x we can write t. So this is t square, right? So therefore dt over minus 2 times square root of 1 minus t square is equal to dx, right? Okay, now we can change the limits. So here see, here x varies from x is equal to 0 to x equal to pi by 2. So when x is equal to 0, then t is cos 2x, so x is 0, so here we have cos 0 is 1, and when x is pi by 2, so we have here t is equal to cos 2 times pi by 2, that is cos pi. This 2 and this 2 get cancelled, so this is minus 1. The value of cos pi is minus 1. So we see that when x varies from 0 to pi by 2, t varies from 1 to minus 1, right? So therefore let us rewrite this integral I as t is equal to 1 to minus 1, and for greatest integer cos 2x we can write t, and for dx we can write dt over minus 2 times 1 minus t square, right? Now we can rearrange this integral as taking this 2 outside, and we can interchange the limits, and we can neglect this negative sign because we know that a to b f of x dx is equal to negative of b to a f of x dx, right? So we have half, and we can interchange the limits. So here we have minus 1, here we have 1, greatest integer t divided by square root of 1 minus t square, right? And dt. Okay, now we see that t varies from minus 1 to 1, and between minus 1 and 1 we have the integer 0, right? So now we can split this integral as a sum of two integrals. So we can write half. The first integral is from minus 1 to 0. So we have minus 1 to 0. Here we have greatest integer t divided by square root of 1 minus t square dt, and the second integral is from 0 to 1, right? Okay, so now we have these two integrals, and we have to evaluate these two integrals, right? Now before proceeding further, let us use the definition of greatest integer function, which says that when t lies between minus 1 and 0, then the value of greatest integer t is minus 1, right? And when t lies between 0 and 1, then the value of greatest integer t is 0, right? So we see that here we can write greatest integer t is equal to -1. So we have half, and we have -1 to 0. Here we have -1 divided by square root of 1 minus t square dt, and this integral is 0, right? Because the value of greatest integer t is 0 here, because t lies between 0 and 1. So we are left with minus half, and we have -1 to 0 dt over square root of 1 minus t square, right? Now to evaluate this integral, we know that the standard result is we have dy over square root of 1 minus y square is equal to sine inverse y, right? So the integral of 1 over square root of 1 minus y square is sine inverse y. So we have I is equal to minus half, and the integral of 1 over square root of 1 minus t square is sine inverse t, and the limits are from -1 to 0, right? Now we can substitute the limits and we'll take the difference. So we have sine inverse 0 minus sine inverse -1, right? So we know that the value of sine inverse 0 is 0, and this is plus, taking this negative sign outside. So we have sine inverse of 1, and the value of sine inverse 1 is pi over 2, right? So now we have minus pi over 2 times 2 is 4, right? So the value of this integral is minus pi by 4.